You won the competition, congrats. Now you're going to the national competition. So you iterated on your rocket design and you decided to first simulate its trajectory on a computer using kinematics, right? So instead of taking it out to the field, crashing it a bunch and needing to fix it, you put in your parameters into a computer program to see its expected performance. Now, in this case, we do assume that all fuel was spent at time equals 0. In other words, it gets this initial boost, but it doesn't continuously propel it. And that's just to keep the problem simplified. We can ignore frictional forces and we'll take acceleration due to gravity as 9.8 meters per second squared downwards. Question A, state the definition of kinematics, or a definition of kinematics. So kinematics is the study of motion, right? How things move, what's their speed, displacement, acceleration, and particularly, like the catch is, it is independent of mass or like external forces other than gravity, or gravitational force rather. So once more, kinematics is the study of motion, of how things move, independent of mass. In other words, if you throw a tennis ball and another ball that's made of steel, but it has exactly the same shape, its motion, its path would be the same if you gave the same initial velocity. However, in reality, things are a bit different, like with resistive forces, right? Air resistance. Cool. So once more, kinematics, study of motion, independent of mass, and frictional forces. Question B. Now, the rocket was launched vertically from ground level, so from a height of 0, with an initial speed of 50 meters per second. Right, and it does say vertically, so let's take up as positive and down as negative. We can ignore the horizontal direction for this problem. Calculate the maximum height reached. So, what are we given? We are given initial speed as 50 meters per second. We're given acceleration. So in kinematics, in the vertical direction, it's often not given to you explicitly. You just need to make the assumption that acceleration is negative 9.8 meters per second squared. And I have the negative sign there because we defined up as positive, right? Which is why the initial speed is positive 50. However, acceleration is acting downwards, so to account for that in our kinematics equations, it will be a negative. What else? Nothing else really given, right? Well, it's asked for the maximum height, and there's a property of the maximum height. So it goes up, reaches its maximum height, and turns back down. So for that moment, that split second, its speed is actually 0. So if you take calculus, you'll know that the rate of change of distance is velocity, and if you set that to 0, right, that indicates a speed of 0 or a turning point. If you don't take calculus, what we need to know is at maximum height, for a split second, its final speed, or its initial speed if you're taking it the other way, its speed is 0. And it doesn't matter if it's positive or negative, right, because it's a speed of 0. So, the aim of the game for a kinematics problem like this is to find 3 known parameters, right, our 3 knowns, and then we're looking for our one unknown. So we've identified initial and final velocity and acceleration, and we're solving for distance, right, displacement. So with that, we then turn to our formula sheet, and we look for an equation, a kinematics equation, sort of near the top, that has all four of these parameters. So one that has initial and final velocity, acceleration, and displacement. So that was step one. Now step two, finding that equation, I see Vf squared equals Vi squared plus 2AD. So double checking that that has everything we need. Yep. That's step two. Now step three. Right, we have our equation, we have our knowns and our unknown. We can substitute in our values and solve. So Vf is 0, Vi is 50, to A, being careful, we include the negative, and D is what we're looking for. Right, so let's work this out. Menu, run math. So 50 squared, 2500. 0 squared, 0. 2 times negative 9.8. Negative 19.6, D. I will then add 19.6D on both sides. I will then divide both sides by 19.6 to give D is 127.55. Now in physics and science, we do need to round our final answer to something sensible. So we were given initial speed of 50 meters per second, which has one significant figure, so we will round our final answer for distance to one significant figure. It does seem a bit counterintuitive, like losing that much information, like a whole 27.55 meters. However, we can't be that accurate because speed is given as 50. If it was given as 50.00, for example, for significant figures, then we could be more precise. Alright, so let's just recap that question. So kinematics question, calculating maximum height. We're looking in the vertical direction. So we first defined up as positive. We then listed out our three knowns, or four sometimes, and our one unknown. We then picked an equation which has the knowns and the unknown. We then substituted in the parameters and solved for the unknown, making sure to round our answer sensibly at the end. Alright, question 2. Calculate the time it takes to reach the maximum height. Okay, so same position, but now we're just looking for time. So we could reuse our three known parameters, or we could even now use the distance. However, if you do use distance, use the unrounded version. Alright, only round our answers at the end. So, let's steal this. Right, because the parameters are the same. Initial velocity is the same, acceleration is the same, and final velocity is the same. But this time, we are looking for time, the time it takes to reach the max. So looking at our formula sheet, have a look for the equation that can help us solve for this. VI, VF, A, and T. I think I found one. So it's the final velocity is the initial velocity plus acceleration times time. So substituting in the known values, final being 0, initial being 50 up, so positive, acceleration being 9.8 down, so negative, t. Adding 9.8t to both sides, dividing both sides by 9.8 will get us 50 divided by 9.8, 5.1, which again to one significant figure is 5 seconds. So it will take 5 seconds for the rocket to go from ground level to its maximum height of 127.55 meters with the given parameters. Cool. Now part 3, calculate the time it takes to reach the ground again. Okay, so a few ways to approach this. We could firstly acknowledge that since it starts on the ground, goes up, comes back down, the time it takes to get to the top is the same as the time it takes to get back down, and in fact we could simply double the time we got in the last question, right, because it's symmetrical. So option 1, the easy method, but it doesn't always work. In this case it does because it's symmetrical. Time to max, so unrounded was 5.1 seconds, therefore time from max to ground is also 5.1 seconds, and so the questions exactly ask calculate the time it takes to reach the ground again. So that would be the combined time, therefore like total flight time or time to ground again from launch is 10.2, or rounded as 10 seconds. Cool. So that is the nice way, right? The easy way. Option 2 is to just use a kinematics equation. So let's have a think. What do we know? So vertical direction, again we have the initial velocity. We have, do we have the final velocity as it hits the ground? Kind of. So if it's launched from ground and reaches ground again, its final velocity is actually going to be this initial velocity, except it'll be acting downwards. But let's try solve it without that. We know acceleration is negative 9.8 meters per second squared. And here's the one that might not be obvious, but it's displacement. So if it's launched from the ground up, okay, that's not a rocket path. Let's try that again. From the ground, goes up, and then back down. Its final point, oh my gosh, that looks quite phallic. Anyway, its final point is a displacement of 0. So that once more, its displacement is 0. So we have 3 knowns: initial velocity, acceleration, and displacement, and we are looking for time. So have a look at your kinematics equation to try find this one. Alright, I found distance is equal to initial velocity times time plus half at squared. Now this equation comes up a lot, It's a very powerful kinematics equation. However, it is a quadratic. And so for those of you who might not take calculus, that just means there are two solutions. And it's a little bit harder to solve, but we're doing physics, so let's make our calculator do the heavy lifting for us. So substituting in the known values, distance is 0, initial velocity is 50, half times a, well, that's half of negative 9.8, and t squared. As a reminder, we're solving for t, so t remains as an unknown. That'll become minus 4.9 t squared. Okay, so I'll show you algebraically first, but then also on your calculator. So I'm just going to put the t squared term first. So algebraically, we could factorize this. I see they have a common factor of t, leaving us minus 4.9t plus 50. Therefore, either t equals 0 or minus 4.9t plus 50 equals 0. Add 4.9t to both sides. Divide both sides by 4.9. That looks to be about 10. Let's double check. 50 divided by 4.9, 10.2. Now let's have a think. Two answers. Time is 0. Well, that's when it's launched. Of course it's at the ground level when it's launched, so that makes sense. But it returns to the ground at 10.2 seconds, or rounded 10 seconds to 1 sig fig, which does line up with what we got the simple way. Right, and if you're looking at that and be like, I do not know how to factorize, that's fine. Once you get to here, you can solve it on your calculator. So I'll show you that now. So after you substitute in the values, make sure you put it in this form. So put the t squared term first, then the t term, and then any constants on the right hand side, all equals to 0. So on your calculator, if you go menu, equa, if you go, instead of solver will only give you one solution. So when we have a quadratic, make sure you use solver, or you could graph it. So F3, excuse me, make sure you use polynomial, F2, polynomial solver. Polynomial, it is degree 2 because it is a quadratic. And see at the top, ax squared plus bx plus c equals 0. So ax squared plus bx plus c equals 0. If your formula is in that form, you can put in the values. So we have minus 4.9 t squared plus 50t plus 0 equals 0. So in for A, we'll go minus 4.9, execute. In for B, positive 50. In for C, 0. Then you can hit F1 to solve, and we see that x, or in our case t, is either 10.2 or 0. 10.2 or 0. Yep, checks out. And so that's how you can solve it the very long way. Right, option 2. Option 2 does work if it's not symmetrical. For example, if we launched and we wanted the time it takes to get, let's say, 10 meters off the ground for the second time, right? This is not the same distance, and the time it takes is not the same. So using this second approach works in situations like that as well. finally, the last question. Calculate the time it takes to reach a height of 50 meters. Well, good thing we did that heavy lifting in part 3, because this is the same problem, except instead of returning to the ground, it's for a height of 50 meters. So, you could do exactly this method, like we did in option 2 here, but instead of d being 0, d is now 50 meters, and we then have a quadratic equation to solve. So let's start with that. Initial velocity is 50, acceleration is 9.8 meters per second squared down, distance, right, we're looking for the time it takes to reach a specific distance of 50 meters. Looking for time using our trusty quadratic kinematics equation. We can substitute in the known values, so 50 equals 50t plus half minus 9.8 t squared. Take everything to one side so it equals 0, and rearrange so it's t squared, then t, then the constant. We have negative 4.9 t squared, so it comes from that, plus 50t, and then taking away 50 is all equal to 0. So back to our calculator, we'll go exit, delete F1, so degree 2 for a quadratic, so that's menu, equation, polynomial, and then you get to this screen. So n for A is negative 4.9, n for B is positive 50, and n for C is negative 50. Alright, so we have our coefficients, we then hit solve, and you'll see our calculator gives us two answers. So to 1 sig fig, that's 1 second or 9 seconds. T equals 1 second or T equals 9 seconds. So what does that mean? At 1 second, the rocket is at 50 meters, and at 9 seconds, the rocket is also at 50 meters. Right, so it goes up, it hits 50 meters, it keeps going up to its max height, it falls back down, it hits 50 meters again, and then it comes back to the ground. So there are 2 points in time that it is at 50 meters off the ground. So that's option 1, and I'll show you another way to solve this, which I personally prefer, and it is by graphing it. So once we get to here, we can graph. And so on our calculator, we go menu, graph, and now what we'll do is we'll graph the left hand side, so 50, and we'll graph the right hand side. So again, left hand side of the equation and right hand side of the equation. Oh, that bit got cut off. So I'll do that now. So y1 is equal to 50, y2, 50. Instead of using t, I will use x, which is under alpha, plus, so that's a half, 0.5 times negative 9.8 times x squared. So I put in the left hand side and the right hand side. I can hit draw, F6. Oop. Here we go. So looking at our graph, it seems to go very high. So let's adjust our window, F3. And our Y max should be more than 50, because we know it gets higher than that. Exit, draw again. There we go. Beautiful. So we can see this negative quadratic and this straight line intersecting through it. And where it intersects, so we hit Gsolve, ISCT, F5, at x equals 1.1 and at x equals 9. So those values of x are actually the time when the rocket is at 50 meters, which is 1 and 9 seconds, as we got previously. Cool. So in summary, in kinematics, in one-dimensional kinematics problems, we first need to identify the parameters. At least 3 must be known. We decide what we're looking for, our unknown, pick our equation, substitute in our values, either solve algebraically using equation solver or by graphing it. And in special situations, for example, question 3, the time was symmetrical, so we were able to just double it. In other situations, we need to assume final velocity is 0, like for maximum height, as well as acceleration due to gravity being an opposite sign to the upwards motion. Cool. All right, happy studying.